This is a Kaleidagraph tutorial with two objectives. The first is to teach you how to make a plot, and the second one is to show you how to perform a curve fit. To achieve the set objectives, we'll use the given example on the screen to demonstrate how to make a plot and also how to make a curve fit. In this example, the question is, we're given an equation below, and this equation can best fit the data that is shown. The question asks us to plot the graph and also determine the value of k, the rate constant. So I'm going to take you down the steps of how to access Kaleidagraph, to use Kaleidagraph to make a plot, and also to fit a curve. So first you're going to go to the Start menu, and then you can search for Kaleidagraph here if it's not appearing in one of these shortcuts, or in this case it's appearing over here. We're just going to click on Kaleidagraph. So this is the interface of Kaleidagraph that we'll be working on. To answer our question, first of all, before we can start to make a plot, we should have our data entered into these cells. So what I've done is I've already created my data in Excel. So I'm just going to take in the data, copy that, go to Kaleidagraph, right click, paste my data. Normally you would, if you don't have your data entered in Excel and your data is in question paper or somewhere, you would have to enter the data manually, everything. Now our data has been entered, but we do not have names of what's what. So in this case, we know our first column was time. So what you do is you double click on the A column and then click once. This enables you to edit and rename your x-axis. So in this case, we're going to have, this is going to be time in hours. Go to B, double click, click once, delete B, concentration in units of milligrams per liter. Okay, so now we have our data, and now we can go to the first step. We just want to plot and see how our curve looks like. So what you do is you go to gallery, and then you choose linear, and then choose scatter. So the plot dialog box appears. This enables us to choose which one is going to be our x variable and which one is going to be our y variable. In this case, our time is going to be our x variable, so click under x, adjacent to the time. And then our y variable is going to be concentration, so under y and adjacent to concentration, click on y, and then click new plot. So our plot has been shown, and you can see everything over here. So now look, because we have one graph, we don't need to have a legend. So we're just gonna left click on that and then delete. Now look at the scale that we have here. Let me just move my graph up so we can be able to see time. Now the scale that we have here in time starts from -2 to 10, but we know there is no negative time, so we can adjust to start at 0. So what I do is go to plot, axis options, and then I want to adjust the x values, so I click on this x here, and then I go to my minimum, delete -2, put a 0. Okay, suppose we had negative values in the y and you wanted to adjust that. The procedure is the same. You go to plot, axis options, and then you click on the y variable. Then you can adjust the minimum value and the maximum value. So now we have created our plot. Now we can see the characteristic plot. All the points are moving here. This is similar to either a first order or second order equation. So now we have plotted our points over here. Now what we're going to do is to try to define the equation that we're given in Excel. Let me go back to my Excel page. We want to define this equation and fit it into Kaleidagraph. If we fit this equation to Kaleidagraph, then we can be able to make it model our given data points that we made. So there are a few things to note about entering equations in Kaleidagraph. I will demonstrate this as I fit the curve. So what we do now to fit a curve, we're going to go to Curve Fit over here. Click on Curve Fit, go to General, go to Edit General. Now notice if you come to Curve Fit here, there are different options of curves that you can use to fit in your model. But we were given an equation and it's not shown here. So that equation we have to manually input it into Kaleidagraph so we can be able to use it on our graph. So you go to Edit General. Now Edit General, you're gonna say Add. Click on Add. So your curve is gonna appear as new fit over there. So you can rename your equation. We're gonna rename this one Tutorial Curve. Tutorial Curve. That's the name of our equation. And we're going to say Edit. Now the Edit option allows us to define our curve equation. So now if you look at the general curve fit for y here, it says y is equal to function of m0, m1, m2, m3. This is how Kaleidagraph works. Kaleidagraph does not use the actual variable names in your equation. For example, in this case we have C0, that's for the initial concentration. This is the concentration at a given time t. This is time, and this is the rate constant. We're not going to write K or CO or T. What Kaleidagraph does is to use M0, M1 as designated names, so to say, for the different variables that we have in our equation. So in our equation, let me go back to Excel. C is equal to C0, 1 plus COKT. So we're going to have C0 to be our M1, and we're going to have K to be M2. Now T is our x-axis or our independent variable. In Kaleidagraph, the independent variable is always designated with M0. So M0 is reserved for any variable that is going to be on your x-axis. So in this case, T is going to be designated in Kaleidagraph as M0, CO is going to be designated M1, and K is going to be designated as M2. So when you come to Kaleidagraph to enter this whole equation, Kaleidagraph does not require you to enter this left side of the equation, C is equals to. All you got to do is to enter the right side of the equation. Is to enter C0 divided by 1 plus C0 KT. But you're not entering C0. Where there's C0, you put M1. Where there's 1, you put 1. Where there's C0, you have M, K, M2, and then T, M0. So now we're going to go back to the Kaleidagraph page, and then we're going to try to input our equation and define it in Kaleidagraph. Let's go. So I'm going to define this equation in Kaleidagraph. So I said my C0 or initial concentration is going to be designated by M1. So that's going to be M1 divided by 1 plus COKT, so that's M1 times K, my K is M2, times T, which is M0, close brackets. So notice I didn't put any equal sign, or did I put any dependent variable in this equation. Kaleidagraph just requires you to put what's on the left, what's on the right side of the equation. Now this is not the complete step for defining an equation. So what Kaleidagraph does for it to start making the curve is to use a few variables in this process. So what we have to do is to define, to give estimates, rough estimates of certain variables in the equation. So in this case we have initial concentration, the rate constant K, and time. Now time is our independent variable, so we're not going to give an initial guess for the independent variable. We're going to give initial guesses for the other variables in the equation. So in this case we're going to have an initial guess for the initial concentration, and we're going to have an initial guess for the rate constant. So this is how we do it. You close the whole equation by a semicolon, and then we are going to define M1, which is our initial concentration, with a rough estimate. Usually what you can do is, given a data like this, let me go back to Excel. Given data like this, we know the initial concentration at time 0 is 140. So any guess which is within the same order of magnitude as your initial concentration in your data will be a great estimate. So in this case, I'm just going to estimate 120 as my initial guess for the initial concentration, semicolon, and then I define the rate constant M2 to be equals to, normally the rate constant is 0 point something. It's normally 0 point something. It's not bigger than that. If you are not sure, you can just Google it and find out what are the relative values of the rate constants in general. But due to the previous knowledge I have with rate constants, I think we can be okay with the initial guess of 0.1, or maybe let's say 0.012. Yeah, this is our initial guess for the rate constant. This enables Kaleidagraph to start processing your equation, really. And then don't forget to put semicolon. Now our equation is defined, and this is one of the most crucial part of curve fitting in Kaleidagraph, getting the right estimates for your variables in the equation. So it's always a rule of thumb, a good rule of thumb, to at least your guess to be in the same order of magnitude as the actual known values of whatever variables that you're going to be estimating. So we're done defining the equation. So we're going to click OK. Click OK. We have defined the equation that was given in the question. So now we want to fit our equation into this data and see how well that equation fits this data. So what we're going to do is we're going to go to Curve Fit, General, Tutorial Curve. Click on Tutorial Curve. Now Tutorial Curve, this gives us the concentration. So concentration, this is the curve, the points that we have over here. These are concentration over time. So now we're going to click on concentration. By clicking on concentration, we're telling Kaleidagraph to use our tutorial curve to fit the concentration data given. And we're going to say OK. So Kaleidagraph has presented us with our curve. So I'll notice our curve is fit into the data, and we can look at the correlation. It's 90.999%. That's a good correlation, and that's a good curve fit. So at this point you can maximize if you want. You can maximize your page just to make sure you have the whole graph to yourself. For editing, you can drag it. You can also left click here and just drag anywhere to reposition your legend. So now, this being the curve, we have to go back to the question. The question asks us to determine the value of k. Now, the value of k is easy to find. We know in our initial equation we defined k to be m2. So we go back to Kaleidagraph. Let's look for m2. This is the value of k, 0.012. We can also find the initial concentration. Well, the question didn't ask us to, but we can still find it. It's M1. Kaleidagraph. M1, 139.4. So notice that this 139 is just 1 milligram per liter less than the initial 140 that our data actually gave. This can be improved by probably making more accurate, should I say, or guesses of k that are like closer and closer to 0.01. But this is good. So we have the values of k. This is our rate constant, and for the second order, it's going to have the units of the second order. And that's it. So now you have made your plot in Kaleidagraph, and we don't need this data here, this point, so just left click on it and then just press delete. Now notice our concentration is like far away from the legend, so what you do is you just left click and then drag, position it over there, left click again. So anytime you want to move the axis levels, just left click and drag. So now you have your graph, your Kaleidagraph. What you do is to just save the file. You can save the graph. So it will ask you what you're going to save it. I'm going to save minus plot 1 at the desktop. I'll save it. Oh, it already exists. I want to replace it. Yes. Okay. However, many a times you are doing this for an assignment in class and you want to incorporate this plot into your Word document that you're writing. So what you have to do is to copy the whole graph and then paste it into Excel or Word, whatever you want whatever you want your graph to be. So the best way to copy this graph is going to be to select a portion that you need over here, right click, copy selection. I'll paste mine in Excel just next to the question, put it there, paste. I have pasted my graph in Excel, just put it over here. Now notice when you copy the graph from Kaleidagraph, it pastes on your Word or Excel as a picture file. So there's an extra space that we don't need. You can just do this by just cropping. Crop. Go down here. There we go. We don't need that space. Reduce it over to here. Crop. There we go. We have our Kaleidagraph graph over here with time on the x-axis, concentration on the y-axis, M2, the K, the rate constant is given over here, M1, the initial concentration, is given over here. Also, since the R is equal to 0.996, that means this second order curve perfectly explains the relationship between time and the rate of concentration depletion in this chemical. So this is a perfect curve fit for for this given data. So let's go back to Kaleidagraph. We can now minimize, bring our data to be, okay, bring everything together. So this was just an introduction into plot making and curve fitting with Kaleidagraph. So when you are done with Kaleidagraph and you have pasted your file into your Word document, you can click on File and click on Exit to exit out of the program. Exit. Save changes. You never know, maybe you made a mistake somewhere, so it's always awesome to just save your changes and you can come and edit it later. Okay. I usually like saving my stuff in the desktop, but I can say tutorial file, save. That's it. Kaleidagraph is closed, and this is the initial question that we have. We have answered the question and we have created our plot using Kaleidagraph. So plot making and curve fitting in Kaleidagraph. That's all. Thank you.